Hey, good morning. We are working towards the end of our packet here. Now, reminder, just because you're at the end of the packet does not mean we are done with Unit 3 quite yet. We got about a week to go. So this is where the add-on packet comes into play because your teacher was boneheaded and forgot a couple of things. So if you haven't gotten this picked up and you're watching this video, you might want to do that. Otherwise, again, everything that's on here is going to be available on the website as well, on the Google Classroom, so no worries. So, okay, solving radical equations algebraically. So we're going to find out later there's a couple ways to do this. We can do it algebraically, we can do it graphically, but since we haven't played with the graphically part yet, we'll stick to the algebra. So we need to remind ourselves of a couple of things before we get started here with these. Okay, first thing, solve each equation. Remember to check for extraneous solutions. Solutions that don't work. Okay, it's going to happen sometimes, yes, but there's going to be a pattern to this that we'll talk about as we're working through these. So that's one thing we can keep in mind. Okay, when we're solving these, basically there's two things I need to keep in mind. Okay, number one, get my radical alone. Okay, so because when we get our radical alone, then what are we going to be able to do? Just like before, we'd always get our x squared alone, and then we take the square root. Now, it's kind of the opposite. We get the square root alone, and then we square both sides. Okay? If you follow those couple rules, piece of cake. Let's jump in. Radical's already alone. Good. Square both sides. All right. Because squaring and square root something is the same thing. 5 squared is 25. Does the square root of 25 equal 5? It certainly does. They all going to be that easy? No, but actually they're going to be much closer to that as far as the easy department goes than you would think. Okay, same thing on number 2. Get the radical alone. Add that 2 over. 8 plus 2 is 10. Again, once we get the radical alone, we just square both sides. And now I just got to keep my squares straight. 10 squared is 100. Square root of 100 is 10. Negative 2 plus 10 is 8. We're good. So we haven't had any extraneous solutions yet. Oh, they're coming though. They're coming. Radicals alone. Okay. Wipes out that radical for us when we square both sides. 4 squared is 16. And now we're just back into a regular old algebra 1 equation. Minus my 4 over. Divide by 3. Again, take a quick moment to check. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. We're good. Okay. Ooh, time for a twist. Okay. What happens if there's radicals on both sides? That's okay. That's okay. We're still going to do the same thing. There's only 1 per side, which is a good thing. If there was more than 1 per side, we can only have 1 per side. Square roots canceled out by the squares. Okay, they're inverse. I shouldn't say canceled out. Now, your choices here are, there's a ton of them. I always like to get my x's together first. And I also like to keep my x's positive. Some of you want the x's on the left, whatever you want to do. I like keeping mine positive, so I'm going to go this way. We should all end up at the same answer, even if you like added the x over or added the 3 first, it shouldn't make any difference. All right, so now we're going to check our answer. So negative 2 times negative 5 is 10. Negative 3 plus 10 is 7. 2 minus negative 5 is also 7. Now, before you get going too far here, maybe you want to go ahead and just be like, okay, so square root of negative 3 minus 2 times negative You're like, I got a decimal. Just stick with me for a minute. 2 minus negative 5. As long as you get the same decimal, you're okay. So you're like, okay, so we still haven't had any answers that don't work. Nope, not yet. Stay patient. Okay, let's see. Radicals alone. Square up both sides here. Now this time I got to be careful because the right side, there ain't nothing there to cancel that squared. That's going to be b squared. Here's the other bit of advice, okay? Whenever you have a squared term that you get, when you get past this step, we want to move everything to the b squared side. Now, I know, you're like, well, why would I do that? Why wouldn't I just minus b squared? Because we're probably going to have to factor here in a minute, and keeping that squared term positive is going to be very important to us. So even though it takes one extra step, one extra little piece of writing, oops, that's minus though. I do have to watch my signs. That is important. This is now a 0 over here. It doesn't mean there's nothing. 0 is different than nothing. And now at this point, you actually have a choice. You can factor it. It's just a regular diamond problem. Or if you wanted to use the quadratic formula, okay, our Swiss Army knife, our tool of all trades, you could use the quadratic formula to solve this too, because your A value would be 1, your B value would be negative 11, and your C value would be 30. Go back in the packet, check it out if you want to. I am going to factor. So first thing, like always, I'm going to go looking for my clues. Okay, remember, my clues are the multiplying number is positive, which means, okay, they're the same sign. They're either both positive or they're both negative. How do I know? Look at the sign of the middle number. They're both negative. And so now I need a pair of numbers that multiply to 30 and add to 11, because again, they're the same sign. So if I'm not sure, maybe I write down some pairs that I know. Ooh, add up to 11. Well, hey, it's one of the pairs that I knew already. Otherwise, I could use my calculator and just divide numbers in until I found what I was looking for. But again, here, don't stop. Okay, we need to know what the actual b value is. So like when we were solving by factoring, we take each of our quantities, each of our sets of parentheses, we set them equal to 0. And that get me 2 answers. But again, check, make sure it works. Again, you can go to the calculator if you want to, or just use your brain. So 11 times 6 is 66, minus 30 is 36. Is the square root of 36 equal 6? Yes. 11 times 5 is 55. Minus 30 is 25. Is the square root of 25? 5. Yes. So it is possible to get 2 answers. You're like, all right, we still haven't had one that has a bad solution. I know, we've gotten really lucky so far. All right, radical by itself. Oh, we got more work this time. Okay. 4v minus 11. Over here, okay. I can guarantee you if I didn't say anything right now and said hit pause, figure out what this is and come back afterwards, I can almost guarantee I can show you what most of you would end up having written down. You would have b squared plus 4. You may have b squared minus 4 if you forgot the sign issue. But most of you do that. You just distribute. Unfortunately, that does not work here. Because we're going to give ourselves a little room up here to work with. Remember, when you have b minus 2, it means you have 2 of those sets of parentheses, 2 of those quantities. And if I have 2 sets of parentheses, I have to FOIL this out. So I've got my first, and my outer, and my inner, and my last. So now I get b squared minus 4v plus 4. So I ended up with a middle term here that I wouldn't have had if I just distributed. I'd have been close, but that would have screwed me up. And just like we saw in number 5, now everything needs to go to the squared side. So I'm going to minus this 4v. I'm going to plus 11. Get that equals 0 in there. Negative 4 does not cancel. If I owe somebody $4 and I borrow 4 more, I now owe them 8. And now we've got it to where I can do quadratic formula, factoring, any of the things that sound good here. Again, plus is same sign, this sign. Multiplies to 15, adds to 8, 5, and 3. All right, before I circle, let's make sure. 4 times 5 is 20, minus 11 is 9. Does the square root of 9 equal 5 minus 2? It does. 4 times 3 is 12, minus 11 is 1. The square root of 1 is 1. Is 3 minus 2 equal 1? Yes. Okay. So let me give you a hint. This isn't going to be true every time, but the ones that don't work typically tend to be the negative. Why? Okay. We're going to make one note here at the bottom. Extraneous solutions, solutions that don't work. Okay. Make the value under the radical negative. Okay. Why? Because what happens when you try to take the square root of a negative? We just talked about that in the last lesson. You get an imaginary solution. Okay, you get a complex solution. And those aren't solutions we could see on the graphing calculator. They don't cross the x-axis. So when you're looking to see if something's going to work or not, basically all you're going to be looking to do is, hey, does this number, when I plug it into the radical side, make the radical a negative? If it does, that's going to be an extraneous solution. That's really all there is to it. Okay? So your job is to deal with some of them on the back, dealing with them algebraically. Then this packet is finished, and we will jump into the add-on packet the next time I see you.